Hey, what's going on, folks? And in this lesson, we're going to continue our SDL C++ programming series, but I have something special for you. And we're going to be building the game Pong from scratch. I'm going to take you through the design document of how I built this, just so you can see some process for building video games. And then you're going to see me build from scratch all of this game right here from all the work that we've been doing in the previous video series. Now, what this lesson is going to uncover, for those of you who are going to watch the whole thing, is that we have some inefficiencies in our abstraction. And the only real way to find those is by building actual games. And this is some advice that I like to give to folks, that you should really build some games before you just jump into building a game framework or a game engine. I think we've built enough useful components that we can see how things work. But that said, we won't really know about the pain points in our code until we try to build something with it. So we're going to move from some of our small demos that we've done in previous lessons and actually build a game. You're going to see me struggle and debug and build some different components and make some notes for things that we'll probably need in the future and could be future lessons in this series. But you could consider this as sort of the pinnacle of the series, meaning that at this point, we have enough components that we should be able to build a game. Now we just need to eventually do some polishing. But before we get to that and continue on to future lessons, let's go ahead and design Pong, and then ultimately you can see me code it from scratch using our current framework. All right, folks, I hope you're as excited as I am for this one, and we've got ourselves a little game here. And I'm looking forward to seeing what you polish up for this project, and feel free to share in the comments below how you expand further on this. Take care. All right, folks, it's time to look at our Pong design document. And this is the document that's going to guide us in building the game Pong. Of course, if you're not familiar with the game, I would recommend that you go ahead and try to find a free version somewhere on the web. I'm sure there's a version. If you just type in Pong HTML, you'll find something. But with that in mind, the reason we do design documents is so we have a plan. In fact, you can read a great book on design documents called Game Design Perspectives. It's a few years old, but might give you a guide. I'm sure there's other design documents you can even find online for reference when you try to build a bigger project. Again, putting everything on paper first or in some electronic document will help you when you start building your own creations, because it's hard to keep everything in your head. So anyways, this is more of an exercise for dealing with Pong and some of the things you might think about as you start to scale and build bigger games. So one of the things we want to think about are the game entities. What types are we going to have? And this will help us think about later the actual software architecture. So clearly, if we just draw a snippet of the game here, we can see we have a paddle, a ball that moves and is dynamic, and some paddle on the opposing side here. So again, this gives us an insight that we're going to have entities, and of course we have our game entity class if you've been following along in the series, so it's likely we'll be using that. As well as we'll have to store some things like the velocity or the speed of the ball and some of these other properties. So with that in mind, how are we going to move around these different entities? Well, we'll have some controls. W, A, S, and D will work, as well as just general arrow keys for moving the paddles up and down. And now the logic. So how does the game actually play here? Well, I've gone ahead and written the rules here so you can pause and sort of think about them, but it is worth thinking about some of these different scenarios. In fact, the hardest part is going to be to get the actual bouncing of the ball right. Here's sort of the trivial case where the ball hits exactly in the center of the paddle, then we'll send it back. But if it doesn't, we'll have to figure out what the right behavior is for sending the ball in a different direction, such that, well, it just has to be believable enough. We could use some trigonometry, and when we get to the implementation, we'll go ahead and make a decision then about what feels right and is fun in the actual game. Anyway, here's some of the logic and the rules and some of the things to think about for Pong. And then finally, we'll need some sort of user interface. So here's the gameplay arena here, but at the very top, we're going to actually need some sort of team score here. And again, we have a dynamic text class for this if you've been following the series, so that you can render some text. Otherwise, any of SDL2's true type font rendering techniques will work just fine. All right, and then of course we have our software architecture. And I'm going to be using the framework that we've built up to this point. So that means having the basic game loop where we have some input, that'll be the key presses, the actual updates that are taking place with the paddles or any of the objects, and the rendering function. We can probably get away with just having something very simple and almost doing this or a lot of the work in the rendering, but again, we'll try to separate out the code into these different parts. All right, and then of course we've got our resource manager that we can leverage for loading the different sprites and assets that we're going to use. That means we'll have some images for the actual paddles and the ball as well. Other resources that we'll need are things like sound effects for collisions, which I'll provide in the repository, but again, you can check some of the previous videos on creating your own effects with SDL and then loading and playing them with SDL audio. And of course, if we want, we could add some background music. We'll see if we get to that feature, but for now, having a little bounce sound so it gives us, or the player, some feedback will do just fine. All right, folks, that's it for Pong here in our design document. We'll go ahead and start doing some implementation. All right, folks, let's go ahead and start coding our Pong game. Now, you probably can't see the text here very well, but this is all the infrastructure that we've built in our previous lessons. So if you want, go ahead and zoom in here, but we've got a couple assets here for sounds, some of the different textures we'll need, and a font for drawing text. So what I'm going to go ahead and do is first make this a little bit bigger just so you can actually read the different text here. And if you've been following along with this series, then you're well aware of the different code that we have. So I haven't actually gotten rid of the source code from our main yet. So for those not familiar with the series, you can go ahead and get a general idea of how our projects are set up. So we have a bunch of different implementation or header files here for various things like different sprites that we want to load, sounds, text, and so on. And we'll create our different game objects here for the different paddles and some sounds that we'll need to load up. Now we've got 3 event handling functions. These are callback functions that are loaded into our main SDL app application. So this is where we'll handle different events, detect if collisions happened or keys were pressed. Then we have our updates that we'll be able to handle if we want to handle various logic, things like moving the ball around in the Pong game will go in here. And then ultimately rendering each of our objects, the left and the right paddle, and the ball, and some of the text. And then our main is where we set everything up. So we have a general idea of what is going on here. Now, what I'm actually going to do is start clearing up and cleaning some of this code and implementing the Pong game just so we have our framework set up here. So in order to do that, let's go ahead and create some game entities. And I'm just going to go ahead and name them something more reasonable. So the left paddle, for example, the right paddle, and we're going to need another entity for the ball. And then what we're going to need for sounds, we'll have our collision sound. And, well, what did I name the other sound here? Well, sometimes it's useful if I just go ahead and name them the same as the final sounds that we have here. So let me go ahead in our assets directory, take a look at our sounds, and we have score here. So I'll just go ahead and call that the score sound. So score sound. Now the different events that we have here. Again, we'll have to handle some of the collisions with our objects and so on. But for now, let me go ahead and just worry about instantiating each of the balls and the paddles here, and our sounds. That way we'll have all the resources that we need in our game up here. Okay, so let's go ahead and scroll down here. And of course, since each of our objects are pointers, we're going to have to reclaim and eventually delete them here. Okay, so let's see. Object 1, that is our left paddle. And we will set that up here. And we are actually going to have a specific sprite image for the left and the right paddle here, just so we can distinguish between each of the different sides here. So that's going to be similar code here, where we add a textured component to our actual paddle game entity. Again, this is what's going to load the rectangle, texture it, and so on with some surface. Okay, and the specific image that we have for this, well, is the left paddle. All right, now let's go ahead and do the same here, and I'm only going to add one box glider here. Now let's go ahead and update the different objects, and I'll have our right paddle as well. Let's go ahead and just update these. And we'll make sure to add one glider. We won't need multiple. Although it could come in handy to have multiple, or maybe it would be interesting to, we just don't need them for this lesson. And finally, we'll need to also create our ball, which is new game entity. So this time doing it from scratch. And we need to get our render so that we know where we are drawing the actual ball to. And let's go ahead and add a component to it. So the textured rectangle component. And this again is in assets, images, and the ball bitmap image, ball.bmp. And it looks like we have the color key here. So again, for folks who are just hopping in because they want to learn how to do Pong here, if I go ahead and step back and just show you the interface for our textured components here, or rather our game entity, and this could be a review for folks who have not seen all the lessons. Well, each of our game entities here has some component here. So we can either add the textured component, or if we have some transparency, then we have a color key. Those are going to be pixels that are ignored so that we can render transparent figures, for instance. Now it looks like I do actually have two different overloaded functions here. So I really don't actually need to specify the different color keys here. So just to go ahead and show what the assets are, for instance, the ball, we can see that we really don't need any transparency. We could make this circular, but again, for this Pong game, it doesn't really matter. So let's go ahead and get rid of these overloads, or rather use the correct overload in our game. And I'll go ahead and leave this as such for our left paddle and our right paddle. And then for our ball, again, we won't need to do anything there. But we will need to also add a box collider 2D. And again, that adds a component. So if we go ahead and look at our entity here, and again, I'm showing you from the header file so you can sort of learn and follow along if you're unfamiliar with this API and just joining us. That is totally fine here. So again, we have a section of code where we're adding all the different components. So let's actually look at what that is in our game entity, where we add the box collider. And you can see that we can have multiple colliders for each of our entities. But for Pong, we just need one for the paddle, or each of the paddles rather, and one for the ball. Okay, so now that we've set that up, let's go ahead and set up some of our sounds. And actually, before I set up our sounds, I do like to sort of keep track of my objects and make sure that I'm also deleting them. So the left paddle needs to be deleted. The right paddle needs to be deleted. And from scratch, the ball also needs to be deleted. Okay, now we can set up our actual sounds here. So we have our collision sound. And let's just go ahead and see how we set up these assets. And I'll move to the asset directory so that we can see everything. And I have collide with a capital C. That's the sound that will be played for our ball, and then the score when the ball moves past each of the paddles. Okay, so let's go ahead and set that up, making sure this is a uppercase C for the collide. We have to set up the device for each of our sounds, which again is a little bit of a pain, but it's how our API works for now. So let's go ahead and repeat this. And we had our score sound that we will do this for as well. And this file that we are loading is just called score. And our score sound, we have to, again, set up a device. And this is essentially configuring the device and checking to see how this sound can be played in SDL, for instance. Okay, and then we should make sure that we don't forget to delete the score sound. All right, and then the rest of our settings here are for setting up the app and actually running the loop and handling each of these callback functions. So if I go ahead and drop in our design document very briefly, we can see that this is part of our basic game loop, and that's where these are being handled here. So very briefly, let's just get a refresher on what our app class is doing. And again, we'll do that by looking at the header file on the screen above me, just so you can get an idea of the architecture. Again, for this type of small project, you probably don't need all of these things set up, but we're thinking a little bit longer term or just how to structure our project. So again, these are just the set callback functions here, which take in some function with a void return type and no arguments. And those are stored here. And those will be called in our run loop function here, which simply calls the events that are being handled, any updates, and then our rendering, which are the things that we're going to handle in our code up in these sections here. For example, handle events. Okay, so we've set up our different objects here. So let's go ahead and start thinking about how to handle some of our different Pong elements, like how are we actually going to move the entities here. So if I actually go into my game entity, let's go ahead and see if we have a way to move things. And in fact, we do. We have a set position that we can set up. Okay, so let's go ahead and go into our event handling here. And that's where we can, I guess there's two ways to handle this. We can just directly detect if a button was pressed here, whether that is the mouse button here. We'll actually have to do this with a keyboard though, so we're actually going to be detecting key presses rather than mouse clicks. And basically we want to update our position of each of our paddles here. So previously the code that we had here in our event loop was handling our application exiting. I do like that here, but we're going to want to get rid of pretty much all of this here, collision detection and these kind of things. Those are things that I'm going to want to have in our actual update function. Now that said, it'll be worthwhile for me to perhaps copy some of this code here, and I'm going to just dump it in update for now so that I can deal with it. Okay, so let's get rid of our collision detection. You can already see that that's sort of cleaning up our code a little bit. It was a little bit of a wonky place to have everything. So essentially we just have our event updates here. And now we want to handle key presses for the left and the right paddles. Now, there's a couple different ways to handle keyboard events here. So one thing that we can do, and I'll go ahead and open up the SDL documentation. So let me go ahead and bring this down here just to give you a refresher on how we learn these things from scratch. I'm going to go to the API reference by category because it's a little bit easier to understand. And let's go ahead and look at keyboard support, for instance. This will give us some idea of how to get key names and these sort of things here. Event handling is also useful for figuring out what types of events that you have here. In fact, let's go ahead and see if we have a keyboard event. And basically, if we read through this, we see that SDL underscore keyboard event is a member of the SDL event. So that's one of these events here. And that's the event.type that we're looking for if there was a key down or a key press. So event.type equals key down is what we're going to be looking for. And then after that, we'll just have to basically figure out, okay, within our actual SDL event here, if it was a keyboard event, that means there was some sort of key that was pressed. So I can revisit this. And then I'll look at, well, what was the key symbol? And then I can look at, okay, what is the actual key code here? And then use one of these values. Okay, so let's go ahead and I'll leave this up here just because we're going to need the key names momentarily. Make this a little bit bigger so that you can see everything. And let's go ahead and handle these event types. So again, the event.type is equal to SDL. It was key down. Then we handle our key presses for each of the different entities. Okay, so we're going to say if the event dot key it was dot key sim and then the actual symbol. And let's actually look through our different symbols here. And I'm basically looking for, say, the W key and the S key to go up and down for our left panel, or our up and down key here. So let me see if I can find up here, and then down, and so on. Okay, so I think we get the idea there. So I'll kind of move this over here, and I just want to keep track of whatever this key was. If that symbol is equal to SLK up, then we are going to do something here. And let me repeat this code here for each of our items. And actually, let me just take care of one paddle at a time. So this will be the right paddle. What we need to do here is set the position here. Okay, so and when we need the actual key codes for W and so on, it'll just be the key names here. Actually, let me just grab that really quick so that I have it and you can see where I learned it from. Okay, SDL key down and lowercase w. Okay, and then the S key will be down for the left panel here. Okay, so I'll make that a little bit bigger here, and now we can see again. Okay, here should be all of our key events. Okay, but how do we actually set the paddle positions here? That's going to be the question here that we want to try to figure out. Let's go ahead and look in our API here, where I have the ability to set the positions. Now, I don't really have an ability, though, to get the actual position of this actual entity here. That's something that I have to figure out. But I do have this textured rectangle here. So what I could do is get the textured rectangle component, and perhaps we can get the position from there. So let's go ahead and see if we have a way to do that here. So what I'm going to do is open up our include, and we want to look at the textured rectangle. And we have the ability to get the rectangle, and we can get the individual X and Y positions. So it's a little bit clunky here, but we are able to do this here. Luckily, we only really have to work with the Y positions, and then we would just always set the position as needed here. Okay, so anytime there's a key down, so anytime a key is pressed, let's retrieve the positions of our paddles. Okay, and I'm going to do this a little bit as a convenience function. C++ will probably optimize it, but again, just working with our API to make things simple. So left paddle X equals, well, we have to go through the left paddle, excuse me. We have to get the textured rectangle, and then we have to get the position Y and X for each of the components here. So get position X here. Okay. And we'll go ahead and, before I repeat though, let me go ahead and comment out the code and just make sure that this much is compiling since we've written enough code at this point. So for our updates, I'm just going to comment everything out because we haven't touched this section of our code. So let me go ahead and leave this as such. And for our rendering, let's just go ahead and render the left paddle and the right paddle and the ball. We can also render. And I'll have some text here. We'll deal with the text here. Maybe I'll call it left score and the right score. For now, let's just have one of them. Let's go ahead and just do this left score, just so that we have some output, and this way we ensure that our build system is also working. And let's see if we have anything else here. So I would expect at this moment that we would have some different or some number of errors here. So let's just go ahead and see what we find. All right, and as expected, we should have some errors here. So I'm just going to work backwards here. Usually I do work top to bottom, but I'm pretty familiar with this code. Oops, 145. So we're missing a parenthesis, or excuse me, a right parenthesis. Our text here, we don't have any counter. So I'm just going to put the left score here, and maybe a colon, and we'll adjust and sort of keep track of those variables somewhere. Let's see, at line 128, looks like this was either an IntelliSense error or my error for rendering here. Line 51 here, we are missing some closing brackets here. So let's go ahead and just comment that out for now. And let's go ahead and try to build this and just see what our progress is. Okay, and it looks like, as I suspected here, I just want to look at the function signatures. This is actually why I paused here, because I believe this is returning an actual object here, or an actual reference to the object. So I should just be using a dot rather than a pointer. So let's go ahead and rebuild that. And voila. And we could go ahead and see if this just works or loads. In fact, if I go ahead and display it, you'll see that, well, there's left displayed here. We need to position our text. The ball here and our paddles aren't to be found. So we'll have to actually set their position somewhere. It seems that the defaults are not in the right locations. Okay, so that is encouraging to see that things are working and ready to go. Now we are getting a lot of debug output here from our font library. That is something I actually just would want to quickly fix here. And that was in a very previous lesson here. So let's go ahead and look at our font, or the dynamic text class. And let's go ahead and just say else if not as. So if the system has not been initialized, let me think about this, because I do want this message to print out once, because it's sort of nice to know that it is working. And by default, it is going to be false. Let me just do a quick rebuild and see if that does the trick. All right, so we compiled. Let's go ahead and give this a run. And there we just see SDL printed out once that it's ready to go, and the font system. So very nice here. Okay, so let's resume with setting the different paddle positions, and we will have to set some default positions as well regarding our window size. Okay, so here's how we get the left paddle X position. We'll want the left paddle Y position here as well. So we'll have to get the position Y. And we're going to repeat these for the right and the left paddle here. So the right paddle X and the right paddle Y. The right paddle and for the right paddle. Okay, let me go ahead and close this just so there's a little bit less noise on the screen, and you can see this all at one line here, in case you're following along as I type. Okay, so now we can actually set the positions here. And again, we'll need to set the default position, but we'll just say the left paddle X, and then the the left paddle Y. Actually, I want the right paddle to be the up and the down key. That makes the most sense here. So we'll set each of those as needed, and then we'll do the same, but for the left paddle. And as such here. Okay. And let's see, the positions here, though, are wrong. There we go. Right paddle Y. And I'll just copy this and paste it in. Okay, so that looks pretty good to me. Let's go ahead and set some default positions just so we can see the paddles show up. And then we'll be able to debug if our keyboard is working here. So we've added the texture rectangles here, but we just never set the position here. So to do so, after we've added our colliders, let's go ahead and do left paddle. We have to get the textured rectangle component and then set the position. And our window is 640 by 480. Let's go ahead and just hard code something for now. So the X position will be, say, 10 and 10 for the Y position. Or actually something more reasonable, like roughly halfway down the screen, half of our height component of 480. That should be reasonable. Let's go ahead and do the same for our right paddle. Right paddle. Okay, and let me make sure I'm just setting the position correctly. I just have a set position function that I can use. Okay. Let me go ahead and keep my game entity code in front of me, just so we can see what our member functions are. And that'll make things a lot easier since we can just use set position there. There we are. All right. And that's a pointer. So there we are. Okay, and let's do that again for the right paddle. And then our ball, we're going to want it to be roughly in the middle of the screen as well. So at this point, it's actually worth looking at our SDL app. So let's open up SDL app and see if we have a way to get the width and the height of the window, if that was needed. So we do have a get window width and get window height. So let's go ahead and just set that app, get window height, or get window width, and app get window height. And that is a function, so we need to make sure that we have parentheses. Okay, let's go ahead and try to build this, see if we made any mistakes, fix them, and see what our output is. Okay, it seems to have compiled nice and well. So let's go ahead and rebuild. And at this point, we can kind of see some interesting things here. Looks like we have some things positioned. Again, I've moved our paddles on top of each other. So let's go ahead and fix that. This should be something like maybe 600, because we have a 640. I think about 590 is more reasonable here. So unfortunately, what we have to do at this point, and maybe this will be a future lesson where we'll improve upon this, is we have to recompile every code change made. So I'll make this a little bit more data oriented in the future. Okay, so we've got our left paddle, our right paddle. We'll have to set the actual dimensions of each of these. By default, our textured rectangle is a fixed size. So let me actually look at our textured rectangle component where I have to set the dimensions here. So let's go ahead and set the dimensions. Now that this has been added, right paddle, get the textured rectangle, and then set the actual dimensions here. So this will be set dimensions. And our paddles are, I'm actually just going to look at the actual asset to figure this out. Display, assets, images, and both the paddles are the same size. I believe they're 200 by 50 here. So let's go ahead and set them accordingly. 200 by 50. Now, again, we could have some default. Maybe this is something we should default to in our textured rectangle to the actual surface size. Again, that's just something we'll have to consider as a addition. All right, so let's go ahead and do this for the left paddle. And I'll just go ahead and update this. Paddle. And our ball, let's make sure that we have also set its position and its dimensions. All right, this is the ball. And our ball, I believe, is something like 50 by 50. All right, let's build that and see if we made any mistakes. And let's give it a run. And looks like we've almost got something put together here. Now, what is interesting here is that our paddle here, I've stretched it when we actually want it to be moving up top to bottom here. So let's go ahead and fix that. Okay, and our ball is off the screen because I forgot to divide by 2 here. And again, our dimensions are flipped. Usually I'm thinking X and Y, but we're thinking opposite for Pong, where we want to think about the width as being a tinier paddle and the height being about twice as, well, in this case, 4 times as high as it is wide. Okay, so let's go ahead and run this. And let's see what we've got. Something like this. So it's starting to look reasonable like Pong. Now we just need to detect if our movement actually moves the panels. All right, so let's go ahead and put this together here and look at our different events. So how are we going to update the position here? Now, this is where we might want to consider if we want to have some global variables or some sort of game state. And one way to do this would be to come at the top of our program here and have maybe some structure here called game state or game properties. And this could be, again, some sort of singleton class, some global, something that's initialized every time that Pong is played. And I might have things like movement speed, ball speed, all of these different properties here. So that's one way that we could approach this. For the sake of keeping this relatively simple, I think I am just going to have this class here. And let's actually work with floating point data just in case we need a little bit more precision to fine-tune our game. And some other things like the ball, X velocity, and the ball, Y velocity here. Okay, so these could be a few things that we might need. Now we're going to need game state. For now, it's just going to be a global variable, game state. And we're going to need to instantiate this and delete it. So in our actual main here. Let me actually give us a new title here. The SDL2 series Pong. And let's go ahead and somewhere before our game starts, set up the game state. So game state equals new game state. And we're going to want to set up some of these values here. Movement, speed. Let's try 1 for now. Let's see how that works. The ball speed as 1. The ball X velocity. And the ball Y velocity. All right. And that'll just give us some baseline. We can tweak these numbers. Again, these are things that we would probably want to load from some configuration so that we don't have to recompile every time that we actually run our game. But I'll leave that perhaps to next video once we have this sample built, and then we can do a sort of more data-driven approach with our SDL projects. Okay, so now that we have our actual movement speed here, we are rendering some things. part of the game state actually should probably be the score as well while I'm thinking of it for our text, so I can sort of finish that off. And those will just be integers, left score, and the right score. So let's go ahead and instantiate those as well. Game state, left score, and by default should be 0. And same for the right score. Okay, and now I can actually print off that text here. Let's go ahead and just take care of our dynamic text, because we really don't have to do anything too fancy there. Whoops, let's go ahead and redo that here. Now this is showing, again, the purpose of the game state, because we're going to need to share data amongst functions. We could pass this into each of the functions if we wanted, pass it by reference. But instead, we just have a global variable, and we're just going to live with that for now. Maybe I'll think of a better solution later. So the left, let me actually just do these as strings. Left score equals left plus, we'll look at our game state and get the left score here. All right, and we'll have to do the same for the right score. So I'll save this here, and the right side. All right, right score. All right, and then we could just pass in these strings here, which makes things a little bit easier. And we probably only need one string, or we could get away with having one string, but for now, let's go ahead and just, again, keep things simple here. The right score. Okay, and their position should be roughly towards the top of the screen. Maybe 0, 0 for this one, and our width is 640 right now. Again, we could try to get the app width and the height. If we wanted, I'm just going to set it at a fixed position and at 0, and let's go ahead and just give this a compile and see if our newly implemented game state is working. Oops, looks like a few different errors here. One that I'm just noticing beyond the syntax error. That we want this again to be our right score. That's a copy and paste error. And let's go ahead and see what errors that we have here. Let's see. It looks like we might need to, or are missing the string library. Let's see. Left score, right score. I think we're just missing the string library here. So we're getting... Oh, and our dynamic text is named the same as our string here. So let's see. Let's fix one of these at a time. Let's make this the L score and the R score. And there we are. Okay. And let's see if we get any more errors there. All right, no errors. So let's go ahead and just give it a quick run. See how things are looking. Looks like our text is, in fact, off the screen. And that looks like I've just made a silly mistake with the dimensions here. This is the X positions. The Y positions should be 0, and then the dimensions can be, let's say, 100 by 50. All right. Now you're probably going to see me compile another 100 times or so throughout this video. Use those as time to just kind of look at the code as things run. But now we've got something like this here. So the left and the right. Now I don't see a 0 there, so that's a little bit concerning that we're not actually getting the score concatenated here. So I wonder if we need to do something like toString. And let's go ahead and see if that does the trick here. Because we want to actually convert this integer and make it part of this string and not something else here. So let me go ahead and rebuild that because it will be important for us to eventually have these scores showing. That's what makes the game a game. And that looks like that is the problem here. So left and right here. I'm going to leave this padded a little bit to the right in case someone happens to play to like 1,000 or something so that this can have some room to grow. Okay, so that looks good enough to me. We will maybe want to center things or maybe adjust the size of the paddles later on. And we might also want to consider putting a border around our user interface and actually constraining the boundaries once we get things moving. So speaking of moving, let's get back to our original test here to see how to move the actual paddle positions and what we are going to do. So for this, the right paddle, if I am hitting the up arrow key, well, again, it can be useful to just visualize this since we don't have things fully functional yet. But that is reducing our Y position, okay? And when we press the down key, we are increasing the Y position, so we should be incrementing. All right, so I'll go ahead and bring this back here. And let's just go ahead and say whatever our right paddle position is, let's add it, well, from our game state, whatever the movement speed is. Okay. Or actually, the opposite of what I said, we're going to decrement there. Okay, so I'll leave this as such here. And we might find out that this is too fast or too slow or whatever the case might be. But again, that's why we have everything in the game state so we can adjust our actual game here. Okay, let's do this with the right paddle, or excuse me, the left paddle as well. And that is the left paddle Y position. And if they hit the S key, then we want to increment. Okay, and I'll put some spaces there. And let's go ahead and see if we've done anything silly here. I'll make the window a little bit bigger just so you can see everything again on one side of the screen. And let's go ahead and run this. And let's see together what the results are. So if I hold down the up arrow key, we are moving up and down. And if I press the W key, we are moving up, and the S key, now we are moving down. But this is way too slow, in my opinion. So what are we going to need to do? Well, just update the game state. And this will give us an idea, too, of what a reasonable ball speed might be as well. I would say we need to move about 5 times as fast. And again, this is just an approximation. All right, so let's go ahead and give this another run. And just so you can see the progress, we're moving up and down. And I would say that's reasonable enough for this game. Now we can move off the screen, which is a problem, so we will have to do some checks here. For the purpose of this video, maybe I'll come back to that and add that. I think you get the point. I think we should actually now get this ball moving and think about some of the things like the collision detection. So let's go ahead and dive into moving the ball. So we do have our ball velocity in the X direction, that's across and up and down, that we will eventually set. So again, let's make these about 5.0, again, something reasonable. And actually, we'll think about how this might be. So the ball velocity could just be a representative number of positive or negative to sort of tell us the direction. And then we can multiply through by ball speed. Maybe that's another way to think about this. And then I can just have these as integers. So let me think about that a little bit. Let's try something like this for now. And I'll slow the ball down to make it a reasonable thing. Okay, with that said, let's go ahead and look at our update here. Because this is where we're going to want to actually be updating the game and moving the ball around and handling some of the other things like collision and so on. So let's go ahead and look at our game state and say if, and this is where I actually am just going to use the X and the Y velocity for our ball and actually just change these to the X direction and the Y direction. And these could be just true or false values, where true is moving in a positive or something, but I'm just going to make these integers here for positive and negative. Okay, so let me update the game state. I'll just make these integers. And let's go back to our handle update. Okay, so game state. So if the ball x direction is greater than 0, then we will set its position accordingly. Meaning that it will be moving in the, say, positive x direction. Else, and let's go ahead and update this. Else it must be moving in the other direction, so we will update the position accordingly. And we're going to do the same thing for our y position. Game state, ball, y direction. Now it looks like I have those velocities somewhere. Ball, y, velocity. Yeah, so I need to update these here. Direction. Sometimes the IntelliSense can help us detect any errors here. All right. Oh, handle updates. Okay, so maybe we can start by grabbing the ball position, and then we will update it based on the direction the ball is traveling. Okay, so we have our ball entity. And let's see what we have here. So through our textured rectangle class, we can get all the positions here, but I just want to look at our game entity to see what's available. We had the ability to set the position, no associated getter function at this time. Now, we could create a getter function. In fact, it might be useful to do that, and then we could use structured binding for folks who are more familiar with C++ and return x and y in one go. That's probably something I do want to fix in this API later on in the videos, just to make it a little bit more elegant. But for now, we'll go through and retrieve the ball x and y positions, as we did previously. And then set them accordingly through our setter function. So ball will get the textured rectangle component, and then we will get the position x and the y position as well. Okay, so depending on the ball x direction, again, if it's, say, greater than 0 or a positive number, then we will increment the ball x position. Plus equal whatever our game state is, and the movement speed. Otherwise, we will decrement. Okay, and we'll do the same thing for the y positions, carefully making sure that we do the y position. And let's go ahead and subtract here. Okay, so let's go ahead and see if I made any, actually let's go ahead and now set the position of our entity. So ball, we'll set the position to the ball x position and the ball y position here. Okay, now again, let's go ahead and see if any mistakes were made. And if all is working, we should just see the ball sort of fly off in some random direction here. And you might catch it, or you might not, depending on how fast I can move it. In fact, the ball is moving in a random direction. So I do want to fix really quick some of the boundaries. That is to say, if the ball goes off of the screen, then I'll put it back into the window so you can see. So set ball boundaries so we don't fly off the playing field here. Okay, if, and basically this is the way Actually, as soon as we've retrieved the positions, this is where we're going to want to check our boundaries. So if the ball X position is less than 0, then we need to make sure that we're in the state where the direction is decrementing. Or rather, let me just sort of match what we have here. So if we're greater than 640, which is our app width, let me just go ahead and do it this way. App get window width. Then we need to change the direction. Let's go ahead and do ball direction times equals -1. That's one way that we could just negate things. Okay, let's go ahead and say if we're less than 0, then we need to change our direction. And we'll go ahead and do the same thing for our Y positions. Y positions. And this time, again, using the window height. And swapping the directions. Okay, let's go ahead and let me just think about this for a moment. Well, let's just go ahead and let me go ahead and give it a build, see if there's any compile errors. And it looks like there's a few because these are part of the game state class here. So go ahead and make sure that I'm updating those in the proper direction. Now, this is something to consider that there's really 3 ways that the ball can move, right? It's sort of got a diagonal direction, right, up or down, sort of moving in the Y direction, left or right. And it could be, too, that the actual ball direction just changes in one dimension, right? If you hit exactly straight on the paddle and the ball hits, it should pop back in a straight line too. So that is one of the things we'll have to consider. That's why I'm just trying to get away with sort of changing the direction, what it is to -1 or whatever. So I could explicitly set the state here if I want, but let's see what we've got here. So this seems to be working well enough here. It's a little bit more difficult on this let's see, the left side, because we're measuring from the top left corner of this actual paddle when we're putting dimensions. So you're going to see it sort of fly off the screen on the right side. So it doesn't look as good there. So let me actually just tweak a few things here. The first thing being with the width of the actual paddles. Let's go ahead and just make those something a little bit slimmer so that they look nice. Maybe something like 20 is a little bit of a more reasonable number here. And then I can also then just adjust the positions here. So this one will be about 610. So I don't want it brushed all the way to the screen. Just aesthetically, it doesn't look as nice. 610. There we are. The ball I'm going to make a little bit smaller. I still want it to be some reasonable dimension, meaning that it's not sort of huge or too small, but just sort of interesting enough to look at. So let's go ahead and see if those changes make things a little bit nicer aesthetically for our Pong game. We don't have to fine-tune an incredible amount. And then I'm going to also just fine-tune this value to say -20 for the ball position. So we do want to see the ball actually go off of screen a little bit here. So I'll do another rebuild here. All right, so let's see how that looks. And our game's starting to look more interesting. I can sort of move the paddles around. We haven't done the collision detection yet, so that'll be the next step. But we do want to probably handle the scoring, and if the ball actually goes out of range here, so behind us, then that should be incrementing and decrementing the points. So now is a good chance to just go ahead and test that again in the condition where for the X boundaries. For the Y boundaries, we don't have to do anything here. All right, so looking at this here, so if the ball position becomes greater than the width, that means the for our game state, the left score is what we actually want to be incrementing. And then in the other condition, we are incrementing the right score. The right score should be incremented by 1. And in each of these conditions, we probably want to set the ball position back to the center stage. And perhaps we want to have a little delay of some sort. When we're actually setting the position here, maybe we want a condition if there was a score or something, just so that things are sort of back to bounds. So we could think about how we want to do this. So I'm just going to put a comment for now. It is kind of nice if after a score the ball is coming the other direction, just for fairness to do. Consider resetting ball in the center if there was a score. So again, that's getting a little bit into game design stuff and not much SDL, which is more of what I care about here. So we can see how our text and our font is updating each time, and we can see the scores here. All right, so now let's just go for something very trivial here and see if we can get, or not necessarily trivial in the sense, but just see if we can get some collision going so that we're not scoring every time. Because right now this is a very boring game of Pong here. Okay, so we've got our rendering, we've got our events, and now we need to be able to handle different collisions here. And we're going to handle this in the actual update here, because this is what we want to sort of check every time. Okay, so what we're going to do here is, and this is some skeleton code that was left over from our engine, again, that we can sort of use as a template for us, but each of our paddles, again, has a collider here. So let's get the box collider, and they each have 1. So we can index into those. Again, if you haven't seen those in the previous lessons, 0 is the first collider. Each of our paddles has 1 collider. And then we want to check, is it colliding with, well, which object? The ball. And we need to check which collider, the ball that we are detecting with, again, each of our balls, or the one tennis ball in Pong has 1 collider. Okay, so let's go ahead and just go ahead and see if this collision can be detected with our left and our right paddle here. Right paddle, and again, it's the same logic here. Okay, so I'm just going to go ahead and get rid of some of this code that we don't need here. All right, and let me get rid of some of these other comments and things that we don't need. And this is all the old stuff from some of our template code. I am going to keep around some of these things that we were doing before with automatically setting the bounding box. We might need that. Let's go ahead and see how resilient our code is. But what we want to do if there is some collision event, again, just to test this out, again, we don't care about which direction the ball is going to do. We just want to change which X direction it is actually going. And we can explicitly set this here. So what we'll do here is let's just go ahead and try, and again, this logic for our collision code, this is the first thing that we want to check here before we worry about setting the ball position and any of these things here. Because it's going to affect the game state, that is which is the ball direction here. Okay, so if the ball is moving in the positive direction here, that means it's collided with the right paddle. So we're going to want to change the ball direction here. in the x-axis. Okay, and that's by default. It is moving in the to the right or in the positive direction. So we can actually just get away with flipping this either way here. So let's go ahead and just try this. And again, our goal is just to have something reasonable where we're not scoring every single time here. Let's see, what have I done here? Our left paddle objects, and we're checking for the collision. Looks like I just copied a little bit too much code here for setting our position of our the tennis ball here. And what else have I done here? Looks like some error with parentheses, sort of a classic that we run into. Let me just take care of compiling and running one of those at a time. And this looks like I am just missing a right parenthesis here. Can't find it. So we'll go to the end of the line, add one more, and now we're matched. And we're going to have to do that one more time here. Again, usually when you see those kind of cascading errors, that usually means that, well, yeah, there's a missing parentheses or something silly like that. So let's go ahead and try our game here. I'll leave it here. So we are scoring here. Let's see if we're getting some collisions. And this is going to be the world's simplest game. Well, it looks like it's not quite working here. And I suspect we are actually going to have to set the dimensions of our colliders from our API. And let's go ahead and see if our automatic function takes care of that. Because that was something that we had to do in our previous lessons. Again, size our actual colliders. Again, we could do that automatically, or we can just set the actual dimensions. So we have those two options here for each of the bounding boxes here. Now this actual set automatic bounding box will work if we have something with a color key, but we really just need to set the dimensions manually here. So let me go ahead and set those up. Now, there isn't really any reason that we need to do this every single frame here. Set our collider dimensions. But maybe you would want to, again, implement some feature where maybe the paddles get smaller or larger over time to make the game harder. So I am just going to implement this. Again, this is a pretty lightweight game, so we don't really have to worry about performance that much. So let me go ahead and just do this as such here. And we can do this based off of the actual dimensions here of our left paddle and our right paddle. All right. And we want the actual dimensions. We don't want to divide by 2 or anything like that. So let me repeat this for the right paddle a couple times. Right paddle. There we are. All right, let's see if we get any errors. And we have something that is up and running here. And this looks a little bit better because I can actually see that I have the colliders here. Now, it is going through our actual things because, well, we've forgotten one, as I usually do here. And that is for the actual tennis ball here. So the ball, let's go ahead and check after we do this if things are working. All right, let's go ahead and give a run. And now I can see the collider actually moving on our object here. Now this is kind of interesting. If the ball gets sort of stuck on our object, then we might have a problem here for how it is moving. But yeah, we have something kind of interesting here. So the last thing that we need to do, besides any fine tuning to the game, such as maybe having the ball reappear in the center, is actually think a little bit about where we want the ball to move after it collides. You can see that there is sort of this weird collision that can happen. It seems that the ball is getting stuck sometimes. So let's think about if we can just have a little bit more principled way of, say, the ball actually hitting objects, or rather each of the paddles, and perhaps bouncing in a different direction just to give a little bit more of randomness. Now, in order to fix the error where it's popping past the boundary, there is a fix that I can immediately think of, which is to let the ball go a little bit further past the boundary. So I'm going to go ahead and implement that. That'll also give a little bit more of a restart time for the ball to come back here. And then we should just center the ball in the middle of the screen here. So let's make this boundary just a little bit bigger. Let's say maybe 100. And let's go the window width plus 80. And actually this one we'll make 100, and this one is 80. Something like that, just to make it a little bit more reasonable. And then what we'll do, again, if there was a score in each of the instances, we will go ahead and set the ball x position equal to the app get width divided by 2 minus 10, because I think the ball was 20 in its dimension. Again, these are things that you could fine-tune later on. To do, don't use the number 10, use actual ball dimensions. And I'll just leave those in as little to-do notes for you to improve upon, once we get beyond this tutorial. And one little compile error, because this is not get width, but get the window width here. Get window width, yep, there we are. And let's go ahead and do the same thing. Perfect. Okay, so that takes care of one of our other to-do notes we had about positioning the ball. Let's go ahead and just get rid of that there. And let's run our program. And, oops, it looks like I maybe have adjusted the wrong thing here. But let's see if there is a score that happens. And it does start in the middle there. Okay, perfect. All right, so let me, instead of affecting the Y position here, let me make sure that I don't mess up this boundary here. You folks are probably watching this happen in real time saying, no, what are you doing? Plus 100. Okay. And we can also set the, we should also set the Y position as well to the center here. So get the window height. Okay, add something more reasonable here. All right. So let's go ahead and run this. And we'll see if there are any, when a score happens, we let the ball go a little bit more. And it also adds a little bit of a more random effect, which seems to be working well enough here. All right. So let's go ahead and address this issue here with the weird collisions here. Okay, and this is a little bit interesting to play now. There we are. I'm going to move one paddle at a time here. So that's kind of an interesting mechanic. We might want to even add some artificial intelligence as well for these sort of things, but anyway, this is good enough for now. The reason we can only actually handle one event for now is because in our event loop, we're only handling one key press. We probably want a different event to be pulled for the left and the right side. Again, I'm going to leave that as something for folks to fix. Maybe it's worth implementing a keyboard class and having separate events for each different key press that you can pull and sort of pump into the event loop and handle them. Okay, anyways, the great part about making a game is it makes you think about these things and how to make your API easier to use, so you don't have to write out all of this code, for instance. Okay, so with that said, let's go ahead and do something, two things. The first is to add a little bit of sound so that you can hear some sound. And if you bear with me, you should be able to hear the sounds. I'm going to plug in one earphone, and we'll go ahead and every time that we have a collision here, so where we're handling our collision, we should play either the collide sound or the score sound. So let me make sure that we have that set up here. So the left paddle, let's do our collision sound, and our options are to play the sound. And then we have our score sound. And we'll go ahead and see how those sound. I'm actually really curious here. Okay, and then we have our score sound. Play sound. And again, anytime somebody scores, we will play that sound here. That should probably be the immediate thing we do, just to be consistent here. Also makes it a little bit clearer what that code's doing and how it's different. So let me enable another audio device, so hopefully you'll be able to hear this. Otherwise, well, we'll figure out what's going on. So we got to compile here, and we'll go ahead and run. And with a little bit of a delay, you hear the different sounds. So we do have sort of an interesting bug here in our sound API, where once the sounds get queued up, they're just going to keep playing here. So I will have to fix that by stopping the sound at some point. And there's sort of a simple fix for that. For now, let me just sort of hack it here and just do a... how should I do this? Let me just do the score sound, and do a stop sound, and the collision sound. I'll also do a stop sound here. Let's see if that takes care of it, because that's all that we have in our API right now. We can't actually capture... oops, let's see, what do we have here? Stop sound cannot be used as a function. Well, let's see what we have in our API. In sound, we do have stop sound here, so play sound and stop sound. Oh, scores. Let's see. Oh, I see. Just extra parentheses here. Okay, there we are. So another rebuild. Anyways, this might be something we have to fix with our actual audio API, which is no problem. But let's go ahead and see if this hack does the trick. Otherwise, we could have, again, a delay. I might just get something to work just for the sake of working. Yeah, now we don't have our sounds if we just stop it immediately after. So I guess the other thing that we could do is just stop the sounds after some amount of iterations or some amount of time. For now, I'm just going to put in that hack because I think that's, we want some sound for this demo here. So this is a bit of a hack, but we want to eventually stop our sounds after some duration. Okay, so how can we do this? We have SDL get ticks. So we're going to need to create a timer. Let me go ahead and show you how I'm figuring this out, this sort of ad hoc hack here. Ticks. And this is just going to return how much time has passed, and if, say, more time than, say, a second has passed, we should just always, by default, maybe stop our sound here. So this is going to be perfect, but it'll be good enough here. Okay, and I'm just going to have some static uint32 is what SDL uses. Let me go ahead and leave this up here. Or I guess it's just using an integer here. We'll get the time, and if it's greater than the last time by 1,000, then we'll just print it out here. Okay, let's just go ahead and work with this code here. Whoops. And let's see here. Now, again, I'm wanting to just, the reason I'm making this static is so that the scope is that it lives forever. Yeah, let's go ahead and just do current time equals this. So it's going to be instantiated once. We'll update it, get ticks. And let's see. Then we'll also have last time here. Also as another static. Again, these could be things that I put into the game state. Eventually, we might want to have some sort of delta time or something like that that we could use, but that's the idea here. Okay, so if our current time is greater than last time plus the 1,000, we are going to stop our sounds, or any sounds that are playing, just to make sure. Now, again, this could have the error that at the exact moment that somebody scores, they don't get that feedback. So again, we'll have to probably rethink, or maybe you can refactor some of the sound API to be a little bit more advanced here. So let's see if this fixes our problem or not. So we are getting some feedback here, some scores. Let's see if the collision works. Okay, it does eventually stop after a second. So there's a little bit of a delay, which is kind of interesting. The other way that we could fix this is we should only detect one collision at a time, and then we could immediately stop, because as soon as a collision happens in Pong, the ball is going to go the opposite way. I'm happy enough for this, and now you sort of know the error as well. Anyway, there we go. That's kind of cool. All right, so I'll take my headphones out. Again, a couple different ways that you can fix that here. All right, so on to the last problem here, and I could get rid of a lot of our starter code here, is just sort of moving the ball in a sort of more interesting way. That is changing the actual y velocity, or when should that be inverted. Right now we have it inverted based off of the if it hits the boundary of the top or the bottom of the window, but maybe we could do the same thing if we hit the top or the bottom of the paddle. Again, just strategically, a player might be able to place their paddle depending on which direction that they want to move things. So that's the idea here. Alrighty folks, so let's go ahead and and within our collision code of each of the paddles is where we're going to handle this. So detection of collision within a paddle. Okay, so this is where we'll decide to how we move the actual ball here. So we'll have to maybe rearrange our logic just a little bit here. So detect where the collision happened. Okay, so if, and let's see, well, we have our collider dimensions here, which we're setting every time. Maybe for the sake actually of just making this code a little bit cleaner, since we don't have any of those gameplay elements, I'll just move these down where they belong here, just to clean up our update. Because this code's going to get a little bit more involved, I guess. So let's go ahead and the basic algorithm is going to be to find out the paddle position and where the ball hit relative to the center, and that's going to determine which direction that the ball goes, or if the y changes or not. Okay. So let's go ahead and figure out the left paddle position here. And to do that, we'll have to get the textured rectangle component and get the position y. And what we'll say is if the position of this y minus the dimension, so the sort of total height, which would be 100. So if that position, which would give us the center here, and let's actually go ahead and try to draw this out just to make it sort of clear. What our actual objective is if we have this paddle here, and here's the middle, and we probably do want a case if the ball hits exactly or around the middle. But let's just say for now, if the collision happens and the ball position is somewhere in this range, towards the middle, or somewhere in this range, so let me make these a little bit clearer, this range or this range, that we should sort of flip the ball direction either up or down. There are certain ways where we'd actually really want to calculate this normal and figure out the angle of the incidence and then sort of reflect it from this point here. But in Pong, what we could do, just to make this really simple, is just if it hits the top half, it always reflects up, and if it hits the bottom half, it reflects down. That could be, one easy fix. And then if it hits exactly in the middle, just send it exactly in this direction. That's what I'm going to go with. It's fun enough without having to calculate normals, because we don't have a math library built in here. Okay, so let's go ahead and, again, the y direction will always be one way if it's the top of the paddle and down. That gives you a little bit of a strategic and predictable opponent way to play the game here. And we are going to need the ball x and y position. Those are the important things at the top of our update here. Okay, so if the when the collision happens, we just want to determine, so let's say this is the paddle midpoint. That's what we're actually computing here. If the paddle midpoint is less than the ball x position, else if the paddle midpoint is greater than the ball y position, excuse me, that's what we're comparing against height here. And then we have our other else condition where the direction is just going to be straight here. So we'll sort of be in no state here. Let me just handle these two here, actually, just to make things a little bit easier. Let's just go ahead and say if it's less than or equal to. We'll say no straight. Again, this could be something that you add later on if you like here. But that's the basic idea. You just have three conditions here. All right, so again, using my diagram, if the ball here is less than whatever this position is, we want to make sure that the direction is going down, if it's less than or equal to. Okay, so how do we determine that? Well, let's go ahead and look at our states here. So if the direction here for the y direction is, well, let's see, where are we setting the actual direction? Well, we're setting the position based off the movement, based off the direction here. Okay, so if it's greater, then we are adding to our position. So we should be adding to our position in this case. Okay. So that means the game state ball direction should just be set to 1. Okay, and we'll go ahead and just test this out, and then we'll flip it if my thinking is incorrect here, because we want it to grow downwards. Okay, so the game state ball y direction equals 1. Otherwise, it equals -1. Okay, let's go ahead and do the same thing for our right paddle. And this will be the midpoint of the right paddle, since that's where the collision happened. And, well, let's see what happens here. Let's see if we actually get to change the velocity in the desired direction. And then we'll be done with the game. Oops, looks like we have a few errors. Let's see. Game state, ball Y direction. Let's see here. Ball Y direction. That's what I meant, but not what I did. So we have to fix it in 4 places because of an infamous copy and paste error. All right, let's go ahead and give that a try here. See if it builds and compiles. No errors here. If I look up here, nothing. And we'll go ahead and, oops, looks like we got a segmentation fault here. I wonder where that happened. So the only place I suppose it could have happened was in this actual game state here. But to be sure, let's go ahead and run our program and see if we can figure out what happened here. Oops, looks like it happened somewhere in our box collider here. Okay. Let's see where I moved our box colliders here. Let's see, layout, source. Let me actually just do a little backtrace here where I'm getting the box collider entity. Okay, so the last major refactor that I made was somewhere in our main where I decided, hey, I should only set those box colliders once. So let's see if I moved them down too far here. That is possible. Let's go ahead and see. Well, let's just go ahead and move things back up here. And we'll go ahead and see if that does the trick here. Now, actually, let's see. For our ball, this should actually be later on here. I'm guessing that is actually the problem here. Let's just set up each of our colliders with as soon as we instantiate them. That's the right thing to do. And I'm going to move this up just so it's a little bit more logically placed here. After we add the collider, we set the dimensions, and then we go on. So let's see if that's the fix. If not, we'll move things back and do a little bit of debugging as we reach very close to the end here. All right. So we've got some things moving. Interestingly, the ball position, or the collider, actually looks like it might need to be adjusted again for the ball. Let's see. So if I hit the bottom part, let's see. Yeah, it seemed to move it down. Let's see. And then I'll test hitting the top part here. I've got to actually connect on this side. All right, let's try again. So the bottom should send it down, and if I hit the top part, it should send it upwards. Let's see. It seems like it's always moving down here, so that means there's probably a problem in my code, probably from copy and paste again. Let's go ahead and check where I do the collisions, and let's see here. If the paddle point is less than this, let's see here, and that's for the ball position. This is for our right paddle, and for our left paddle as well. Let's go ahead and see if I just have these flipped around. That's always a quick test, and then otherwise, well, maybe I just need to rethink the algorithm here. So let's go ahead and rerun, recompile, and let's see what happens here. And I'll bring it up here, and we actually need to connect here. And that's sort of the randomness that we have to take care of. So that sends it up on the bottom part of the panel here. Let's see if I hit the top, does that send it down? It seems like it's always sending it in the up direction here. Let's see. So that'll send it up here. Yeah, let's see here. let's see what's going on here with our right and our left panel here. So I think it is one possibility. We do have to think about where I am detecting these collisions and then actually moving the ball here. So let's actually see if the ball position is affected anywhere else by the ball direction. So ball Y direction, just so that we can sort of highlight things. Here's where we're changing it based off of the panel midpoint. And in order to debug this, what I probably want to do is let's just work with the left panel and the rep paddle, since they're doing the same thing, and let's just print it out in real time. Now again, this is where we're really needing a logger class or something. In SDL, we have SDL log, which we could use, but we might want something that sort of samples every once in a while in our game to print out some data. So let's go ahead and just run this, and let's see if every time I get a collision, where that midpoint is. Okay, so it says the midpoint is at -55. And I think I actually know what the problem is here. Let's see if I send this down here. So the midpoint I'm subtracting from, I should actually be adding because the Y position goes down here. So let me go ahead and add here. I think we were just always getting negative values there, although we'll check. We'll have to do another round of debugging. Here we are. And some of you folks probably spotted that faster than I did, but we'll see if that's the fix. All right, let's give it another run here. I got my headphones in so I can hear the sounds. And let's see what happens here once we actually connect. Hits the bottom and goes up. And let's see, if it hits the top, then it would go down. Let's see. Hard to tell there, so let's try with our left side. And that seems to be reasonable. And let's see, if it hits the bottom, then it should go up. Okay, I will buy that that is working now. And just like that, things are good to go. So there's not too much strategy in this Pong game here. And the last thing that I want to take a quick look at here is to see if I can fix this little collision box here, and then we will call it a day. Then I'll give you sort of a list of features or other things that you could consider implementing here. So I just want to see, because I'm setting the collider, looks like I'm just doing something out of order here, where I'm setting the dimensions right when I'm doing the collider here. So let's go ahead and just set the dimensions first, and then set our collider. I think that's the suspected bug here. So we'll go ahead and see if that works. Meanwhile, I will go ahead and I want to remove that debugging code in a second here. And there we go. That looks much better this time. And oops, we've actually managed to get the ball stuck here. And I can move it off the map as a fix here. So actually, before I go, this is going to be something that we want to fix to make sure that the ball doesn't get stuck here. So let's go ahead and fix that next. And in order to fix this, basically we're going to say, hey, if the ball is at any point behind the paddle, just don't detect any collision. That means, you know, a score has happened. So this is also going to, I think, prevent the other errors where the ball was sort of flying through the objects and getting kind of stuck behind them. Actually, that's a good bug to fix here. So we're going to go to our update here. And as part of our collision check, basically what we're going to say is if the left paddle, and we'll get the textured rectangle, and get the position X. And again, we'll have to be a little bit precise here because the position of the rectangle is in the top left corner. So plus 20. That will mean that that'll measure us from basically the right corner of the paddle. So let me go ahead and draw this here, just so you completely understand what problem we're trying to fix. Basically, I've got to do a little offset. So from our paddle, instead of measuring from this corner, we measure from this corner right here. Okay, and that's the point where we want to say, hey, that's the point of no return if the ball actually goes past. Okay, so if whatever that position is, if the ball X position is less than that, then we basically want to ignore the code here. So let's just go ahead and say if it's greater than that, fine, it's in play. We can check for collision detections. So I'm going to just wrap all of our collision detection code here in that line here. And then I've got to do the same thing for our other paddle that's on the right-hand side. Now, for the right-hand side, I don't have to do that offset. I can get away with not worrying about that. Let me go ahead and just wrap this code here. And put a closing right curly brace. And so we don't need the offset, and I just need to make sure that I am comparing against the right paddle. Okay, let's see if that did the trick here for fixing a bunch of bugs. All right. So now if we run our game here, let's go ahead and try to collide. Looks like we're getting some collisions here. Although it looks like now our left-hand side's not working here. So let's go ahead and see what's going on here. Gonna let it bounce a few times. Our right-hand side is working, but not 100% as I would like it. So let me just fix these up here. So if the ball position is for the left-hand side, well, let's try to think about this here. This, in theory, makes sense to me, that the ball X position would be greater than the left-hand side. And let's just go ahead and see what's going on here. Well, likewise, if for some reason these are a little bit backwards, now I wonder if I just switch the left and the right-hand side, that'd be a little bit silly. It doesn't look like I did that. Now, the easy fix, again, would be to just think about, I suppose, also which direction the ball is moving, which could affect this. So I guess my sign is opposite here. Let me just give that a try here. So if the ball position is less than the left-hand paddle, well, let's see if that does the trick here. Let's see if we get some collisions here. Doesn't seem to work here. So I have to move it off the map to restart. Okay, that one collided perfectly. Let me bring this paddle back here and see if we're just getting stuck here. All right. For some reason, that logic seems a little bit backwards to me. But maybe the ball position is something that we can return here. Ball X position. And let's just go ahead and print that out. Now, by now, in a bigger project like this, I would likely have some logging functions, like just log integer, and it'd print out what the integer is. This is where things like reflection and so on can come in handy. Left paddle position. And we're just going to print out basically this whole thing again. Left paddle, get the textured rectangle dot get position X plus 20. And that'll tell us the corner that we have our rectangle in. Okay, so we're going to see that every time if it is satisfied or not. So this will also increase my confidence here. So the left paddle X position is 30 here. I can see where it actually got stuck, and the ball position here is fluctuating between 0 and 5. Now it is having some collision here, so that's kind of the backwards part here. So there's actually an easier solution. I am, just for the sake of closing this video instead of debugging for forever, is, let me get rid of this. Let me unindent this. And I'm going to get rid of this code here as well. And unindent. And just have our code. I'm just going to check that the ball position is greater than a specific value here. So if the ball position of X is greater than, and I actually know what this position is since we just debugged it, 30. So 10 the offset plus the panel width. And the left panel, that will work fine. And I can do the same thing here, basically. So if, and actually I want to be a little bit more precise, I should say greater than or equal to 30 to get an exact hit here. That's the only time that we want to actually detect a collision. Well, likewise, here, if the ball X position is less than or equal to 610, that's an offset of 10, and then it's also where exactly that left-hand corner of our right panel is. Okay, let's see if I just misspelled one thing here, and then we're getting close to the close here. And oops, again, I just will undo that change and make this lowercase p and recompile. Alrighty, so let's go ahead and give this a run. And let's see what happens in our game. That looks good. And our left side just does not want to work here. So let's go ahead and take one more moment to try to debug this here. Let me go ahead and just close this down. Okay, after a quick debug, I found out the magic number here is sort of 25. So I'm just going to give this a debug. And why is that number 25? Well, again, the ball size here is, let's see, is about 20. And let's see where we positioned our paddle, which is also 20 here. But for some reason, that just seems to be the magic boundary size here. Anyways, let's go ahead and play our game here. And we can see how it's actually running here. So let's go ahead and get a hit here through the top. And this seems like it's working well enough, so it's just going to send it back and forth. Now, at this point, you might notice that I'm not doing anything super interesting as far as, again, the angle of instance, and I sort of like that because it's helping me test the actual game that I have here, so that we can actually play and make sure that things like the collision and so on are working. So again, I'm going to leave that as an exercise for people to compute the normal and then take the cosine and so on to sort of change the direction to not just be a 1 or -1 value here. So for now, the sort of variance that you get is to change the where you hit the ball with the paddle here. And it's moving at a relatively interesting enough pace here that it seems to be working here. Now, it's still a bit of a mystery why that value is 25, so I just want to take one more look because I never like magic in any of my actual videos here. And let's go ahead and see here when we set the dimensions, set the position, and all these different things. 25 seems to be working just fine. I have offset the paddle by 10. Okay. Well, nonetheless, it seems to be working just fine enough, and you get the idea that this is Pong here. Now, it does seem that I am, I suppose, I have some of these, again, magic offset values of 10, again, that we don't want to use here necessarily. Anyways, there you have it. There is Pong running. I'll go ahead and take my headphones out. And let's go ahead and wrap this one up here. So what you can see here is the game actually playing Pong, and it's been quite a adventure programming this. So hopefully you have enjoyed this sort of live stream format or recording of basically everything built from scratch with what you've learned from SDL2. Now, again, you'll notice, and part of the exercise here is that building an actual game is going to uncover some of the flaws in your API. And some of the things where you could say, well, I wish I could just do this easier or have more helper functions to do these things. So as I was recording this, I was going through and sort of noting down some of the different things. I said, hey, wouldn't my life be much, much easier if I had this helper function? Or maybe I could restructure things in a different way. And again, a great way to learn is by building some of these classic games, because you're going to run into enough interesting problems as you build the game and see how your software architecture really affects your overall program design. So folks, with that said, I'm going to go ahead and close this lesson out. I hope you've enjoyed it. And if you actually watched this entire video, please comment below. And if you just were able to get the Pong game up and running and made some cool adaptations, definitely comment below, give a like, and I can't wait to see what you've built. All right, folks, thank you for those who made it all the way through or part way through this video, and I hope you're still learning some cool SDL stuff. We'll see you later.